we do assume that you know a few things from your geometry days, and I know you did it in Algebra 1 as well. You need to understand what slope is. Um, the first lesson is about knowing knowing the solution of a group of linear equations. Now, solution means, so maybe we should write that out. Solution means intersection point. So that's where they intersect. Intersection, boy, this is really bad, point. Okay, so wherever they cross, that's what we're really looking for. Okay, so in order to graph these, you need to be able to go back to your days of what's the slope, what's the y-intercept. Obviously, the 8 is the y-intercept. So we know right then and there that there's a point that it's crossing the y-axis. Your x value is 0 and y value would be 8. We also know that it has a slope of 1. And of course we know that the slope of 1 can be written 1 over 1. And you've talked about that, rise over run. And yes, folks, I spelled it the wrong way so that you would remember that the y's are on the top. And if you go look up the definition of slope, you will see that. But you can do the whole up 1 over 1. I'm going to use the line creation tool to go up 1 over 1, up 1 over 1, up 1 over 1. Problem is, I don't know if I can do this really nicely. Going the other way, I shouldn't have done it like that. Let's try that over again. Boom, boom. And we'll do this. We'll start up here. You know what? I'm just going to try to draw it myself. If I'm careful, it'll work out. If I'm not, I'll probably ruin it. Okay, so now I've got a y-intercept of -2. Find that y-intercept. It has a slope of -1. So that is down 1 over 1, down 1 over 1. So it's doing something like this. So should have put some arrows on the green one. There is the intersection point right there at the point -5, 3. Okay, so that's the solution to this particular question. All right, let's go to the next question. Oops. And can I slide that up? Good. Okay, continuing to solve by graphing. Same concept, right? You've got a y-intercept at -8 down here. This one has a slope of 4, so that's up 4 over 1, up 4 over 1, up 4 over 1, up 4 over 1. Oops. Yeah. Hopefully I got that pretty well down. And then I have a y-intercept of +4. And -2 over 1, that would be down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And I can see that the intersection point right there is at the point 2, 0. Okay, that's graphically finding what's going on here. Let's go to my next question. In this case, I'm going to have to put them into slope-intercept form. Now, there's another way to handle this as well, and I could show you how to do it with, and this might be a nice way to do it if you're thinking about SAT or ACT, how to quickly find the slope. If you solve for y by using this really generic form, by equals -ax plus c. So I subtracted the ax term to the other side, and then I divide by b. Well, what I'm hoping that you see, just from your days in Algebra 1, remember y equals mx plus b, I'm hoping that you see that right there is your slope. That's your slope. So the idea here is that slope, you could easily see what the slopes are. Now, that tool that I'm showing you is sometimes a very useful tool, and in fact, it'll be more useful in the next section. But let's see here. So we would do the same type of thing. 9y equals -3x plus 9, because I'm moving the 3x term to the other side. and then dividing by 9. Now, if I divide everything by 9 there, I am hoping that you see that we can reduce this to negative 1/3 x plus 1, right? So we know that it's got a positive y-intercept, and it goes down 1 over 3, down 1 over 3, down 1 over 3. And so we have this shape right here, and hopefully I did enough. And then the other one we can do, if I solve for y, that's pretty easy, negative x minus 1. So it has a negative 1 for the y-intercept and a negative 1 for the slope. So it's going down 1 over 1, down 1 over 1, down 1 over 1. Which means it's more interesting to see what happens on the other side, right? Because that's where we're getting the intersection point from, which is right here at negative 3, positive 2. Okay. This is a little bit different question. We have here x equals 8. That is a vertical line. And then the other one, y equals 4. You'll remember that from your days in Algebra 1. If you don't understand that, x equals 8, the vertical line looks like this. That's because every point on that line, like 8, 0, 8, 1, 8, 2, 8, 3, 8, 4, they all have an x value of 8. And then, of course, the other one, y equals 4. Every coordinate has a y value of 4 on that. So this is pretty easy to see that it's 8, 4. Now, if you're thinking about it, I basically handed you the intersection point right there. But that's a real generic situation where you're dealing with vertical and horizontal lines. We could do vertical. The other kind of lines are called oblique lines. Question 5, and I believe this is the last one for our section here. Question 5. Solve each system by graphing or using a table. I'm not going to use a table. I'm going to graph it. So we're going to solve these things for y. Negative y equals 2x minus 2. So y equals negative 2x plus 2. And then, of course, my other one, 2y equals negative x minus 2. And if I divide everything by 2 there. Now, this one becomes y equals, now watch that, negative x over 2 is the same thing as negative 1/2 x. And then, of course, 2 over 2, in this case with the negative, would be negative 1. So let's graph that one first since we got it here. Negative 1's my y-intercept, down 1 over 2. You got to watch the scale here because each block is worth half a unit. So down 1 over 2, and likewise up 1, back 2, up 1, back 2. And see, here is your equation for the red line in a very quick format. And then in plus 2, and we're doing down 2 over 1, down 2 over 1, down 2 over 1. And obviously you could see the intersection point right there. So the solution to this one right here is 2, negative 2. We'll talk about what happens in the next section. We'll talk about infinitely many solutions where the two lines actually would sit on top of each other. And what if they're parallel? If they're parallel, they don't cross. We'll talk about that in the next one.